Welcome back. In this session, we are going to revisit one of the key big data concepts, partition pruning, that we discussed in the discovery section. For big data workloads, it's important to be able to prune partitions to get the optimum performance. It'll be impossible to read the entire data set and perform analytics in large amount of data. Unfortunately, external tables in Synapse serverless pool cannot prune partitions, so it's not recommended for partitioned datasets. For example, our trip data file, which was partitioned by year and month, but we cannot target the specific partition via external tables. So the solution we have implemented is not the most performant. Having said that, we can achieve this with a combination of views and open row set function, and this is the recommended approach from Microsoft as well. Let's switch over to Synapse Studio and I'll walk you through the problem with the external tables and the solution using views. Let me start by defining the problem. First, let's head over to the data hub and the underlinked. Actually, we have seen the data here. We've seen this a couple of times, but I'll quickly walk you through it. So for the trip data, we've got the data partitioned into a year and month. So in an ideal world, then I want the data for year 2020 and month 01. I should be able to specify that in my where clause, and then the query engine would come and read just this one single file and get the results I want. I wouldn't want the query engine to read all of the other files as well, but the issue is that in external tables there isn't a means to target only the year 2020 and month 01. Whenever you run a query, it's going to go to this folder here and grab all of the files. In this case, actually, I think we've got about 18 different files across the 2 years, and it's going to go through each single record and give us the data we need, which is not the most efficient way to do it. And it wouldn't perform well in a big data project with terabytes of data or petabytes worth of data. So let me show you why we think actually it's not possible in an external table. We just created the external table for our trip data for our CSV, Parquet, and Delta. Expand the columns here, you won't be seeing a column called a year or a month. So there isn't a means to target that partition at all, even if you are asking for the data for a specific pickup time, which falls in, say, year 2020 and month 01, it will still be scanning the entire data set and then give you the results, which is not ideal. This is the same for the Parquet as well as Delta as well. Let me open up those as well. Parquet doesn't have year and month. Having said that, when we did the discovery, we talked about the same problem and we achieved it using the file path function. Let me go over to the scripts and show you the script that we did. So if I scroll down, I see you can see the use the file path 1, which will be the wildcard here. 1 which is from the year, and file path 2, which is from the second wildcard, which is the month. To expose the year and month. And then we use that in our back. So that means in this example it would target the partition 2020 year and month 06, 7, and 8. So that would only target the 3 partitions we've specified here. That's exactly what we want. But as you can see, using the file path function here, we can export the year and month and we cannot write a select statement like this. And from the previous lesson we learned that a view basically is a database structure on top of a select statement. So we can take this select statement and wrap a view around it. And then now the view could be exposed to everyone and they should be able to run a query to target specific partitions by specifying the year and the month. So that's what we are going to do. I'll quickly show you how we could do that. I'm going to just open up the Create Bronze View script here and then we'll start making the changes. Let me copy the select statement from here and wrap it in a view, as we did before. I'm going to do create view and then I'm going to put that view in the bronze schema and I'm going to call that as VW_trip_data green CSV as, and then I've got the select statement. But in this example we had count, but we don't want to count. We want all of the columns. So I'm going to do select result.star. Todd may need to make a couple of changes here, which is the data source. As we know, I'll be using the src data source here and also we need to put the folder path raw/. So now let's execute this and that should clear the view for us. Let me see. So the view has been created. Let's now head over to the data hub and then have a look at the view. So the view should have the columns here and the month as you are seeing here. So now whenever somebody is doing a query, they will be able to include that in their class and target specific partitions. So let me show you that I had to select count from this table, which is our bronze view, and it should give us the total number of records. Let me just run that through. As you can see here, we've got 2.3 million records. But if you look at the messages, it's kind 209 meg and there is 1 megabyte of metadata as well. But if I just add that, where clause, let me do that and say year equals 2020. And month equals 01. It should only target that partition and it should scan fewer number of records, or it should scan fewer amount of data. So that's got about 447,000 records. And as you can see, it's only scanned 82 megabytes. With that, the query has only scanned about 1/7 to 1/8 of the data. It's kind in the previous query and the response is pretty quick goes, well, you don't possibly see the difference in response times here. That's because we're dealing with the low amount of data. But when you're dealing with the terabytes of petabytes worth of data, you're going to see that difference. Let me quickly add the with clause here so that the data types are all defined as well. So we've had that data type defined on the other query in our Parquet files, I think. So I'm going to quickly grab it from there. So we've got the with clause and that goes up to there. So I'm going to just quickly copy that and paste it in here. And now we've got the with clause with all the columns being defined as well. And in order to rerun it, we need to drop the view. So I'm going to quickly copy the drop statement from the previous query and put it here, and we're going to change the table name as well. So that's now recreated the view. I'm going to do a select top 100 from the view just to ensure that the data looks as we expect it. The query failed because I missed the star. I'm going to put that back in and then just run it through. And we should see the top 100 records, and we've got the year and the month, as you can see, and the rest of the data as well. So that's how you achieve partition pruning. So remember this. This is very important. If you have data that's partitioned in your files, please don't use external tables instead of views. With a combination of open row set, and that is the most efficient solution. So this is as of today, but I'm hoping Microsoft will bring in partitions into external tables at some point. But at that point we can switch over to using external tables. But as of now, this is the solution proposed by Microsoft to use in order to target partitions. That's the end of this session. I'll see you in the next one.